Welcome back to our lessons on electrochemical cells. We are going to look at some very useful ways we can use electrolysis to do some amazing things, like purify solid metals and even cover one metal with another. But first, let's study a simple example of electrolysis of copper 2 chloride. When we see that a brown powder forms on the negative terminal and a gas smelling like bleach or pool chemicals forms at the other, I need redox to help me understand what is happening. The reason we use carbon rods is because they are inert or non-reactive. They also conduct electricity, which is important to make the reaction happen. Using the standard electrode potential table and circling the copper 2 plus ions, water and chloride ions, we can see that the copper 2 plus is the best oxidizing agent. And even though water is a better oxidizing agent than chloride by a tiny amount, the chloride ion coats the anode and prevents water from reacting. So, writing out the half reactions, starting with copper ions and chloride ions, we get our two half reactions. If we quickly calculate the voltage required to make this cell reaction happen, we see that we need 1.02 volts to make this non-spontaneous reaction happen. So, I'm hoping you can see how this reaction could be used to make metal form its ions. In this example, we see that we've attached an iron spoon to the negative terminal of a battery and applied a positive charge to another block of silver on the opposite side. The solution has silver nitrate dissolved in it to make the solution conductive with ions that can move. When the electricity is allowed to flow, silver ions are attracted to the negatively charged spoon and reduction occurs. That means we are making a layer of silver metal on the iron. So cool! On the other side, silver is being oxidized and making more silver ions. So, if we leave the solution long enough, we will see the silver block growing smaller and the spoon getting heavier, slowly growing with more and more silver metal. We can use the same oxidation and reduction process to purify copper that is made from mines. The impure copper has zinc, silver, and other impurities like platinum. So, when the copper is oxidized, both zinc and copper are oxidized, leaving the impure block. At the cathode, the potential is not high enough to reduce zinc back to a metal. So, only copper is deposited on in 99.9% purity. Amazing! Of course, the leftovers are metals that are difficult to oxidize, but are valuable. Did you know that one of the world's largest producers of silver metal is actually the copper industry? Those leftovers are worth a lot of money. So, I hope you've learned a lot about electrolytic cells and how they can be used to make chemicals and purify them. Make sure to practice, as electrochemistry is a very large part of chemistry and needs a lot of thought to be done well.